All right, I'm going to share my screen and we're going to do the College Algebra Test 4 study guide. So let me get my screen up here so y'all can see my notes. All right, here we go. All right, so the first page on the study guide, they was wanting me to play with the graphs. So these graphs we can do right in our calculator here. So let me turn this on. So I'm going to put it in just like it looks. Go to my y equals. Let me clear that out. 1/3 in parentheses, so I'm going to put it in parentheses. 1 divided by 3, close parentheses, and then do your exponent with that arrow up key over here. Push that, and then our exponent will be the x. So now we can graph this. Now notice, if you wanted to change it to match their graphs, they got 5x5 graphs. We could push this window button and change the values from -10 to -5 for the x minimum, 5 for the x maximum, then go down to the y's and do -5 for the y minimum, 5 for the y max. Then when we hit graph, our graph will look just like one of these. And we know since it's a fraction that it's going to go downhill left to right like when we was in class. So over here, the one that goes downhill left to right and does exactly the same would be D. All right, number 2 is the same thing. It has f of x equals 2 to the x plus 5. So down here, they wanted me to tell about the moves, and then over here, sort of graph it. So right here, since that is x plus 5, anytime you attack the x, you move left or right. You move left if it's added. You move right if it's being subtracted. So since that 5 is being added, we're going to move left 5 units. So this one says left. So this is what we want. So we're going to start with the graph of 2 to the x, because 2 is my base, and then shift the graph 5 units left. Now remember, when you graph it, you would come over here, you would click the tool that looks like the exponential. It'll say exponential when you highlight it. Click it over here, and it'll put that somewhere on that graph. And it'll draw that line going right there for you. But it's going to pull up another box. Now, since we were going left or right, that would be the horizontal. So find the one that says horizontal and slide it to the left 2 units and get over there at a -2. Okay, so when it's positive, it goes left. If that would have been a minus, it would have went right. All right, y'all, let me get this next one. So one more with a graph. Oh, and then we could have graphed that last one. So let me go back and graph that last one for you real quick to show you that you could have graphed that and seen what it did. So clear that out. We could have put 2 and then pushed the exponent and then pushed x plus 5. Now, if you got the old calculators, when you do that, you're going to have y equals. You're going to push your 2. When you push the exponent, it's going to put, whoops. A new pen, y'all. So when y'all push the exponent, it's going to make a parentheses. You got to put x plus 5 inside the parentheses and close it. You got to close the parentheses so that it knows the whole thing is your exponent. So that's only on the older 83s and 84s, okay? If yours does exponents like mine and keeps it all up there, then you're good to go. So now, this graph looks like they went 10 and 8. So to get close enough, I'm just going to hit zoom and go down to number 6 for standard. So when you hit zoom standard, it's going to give you a pretty much 10 by 10 graph. And then we can see what it's going to look like when we get done plotting it on here. And you can see this did cross over here, so it did shift over 5 units and went to the left. All right, now number 3, sort of the same thing. So first, our base, the graph that we start with is going to be 2 to the x. And then it says shift it blank 4 units. So since that 4 is up there with the x and it's positive, we know that's going to shift it left 4 units. Now this minus 2 is at the end of this graph. So since the negative 2 is at the end of the graph, that's going to shift the graph down 2 units so that it's going to go down 2 units. So here's the answers you would have picked. A, and then down, okay? All right, now we got to graph it. So I can graph it on the calculator. But over here, same thing. You click the graphing tool. You want the exponential. It's going to put it on here somewhere. It's going to pop open a box. So since we went left 4, you would slide the horizontal left to the negative 4. And then since we went down 2, that would be your vertical. And then that would go left down 2, okay? All right, when you graph that, let's see what it's going to look like. So clear. And they're pretty close to a 10 by 10, so we'll be all right. So we got 2 exponent x plus 4. Arrow right to come down. Now, the older calculators, you would have 2, hit the exponent. It's going to put parentheses, put x plus 4, then close the parentheses. Now, we arrowed down, so we're going to put what? Minus 2. And that's the same thing y'all would do, put your minus 2. So when we graph it, we can see how it went left and down, right? It pulled it left and it pulled it down so that it's sort of down here and then goes up, okay? All righty. So now I'm going to use my pad to write on. So number 4 tells me that 83,000 is invested at 6.5% interest compounded quarterly. All right, so A of this wants me to find a function for the amount to which the investment grows after t years. So that's going to be in this form, A of t, okay? So we know P is your principal balance that you start with. So P for us is going to be 83,000. So we're going to put that in there. And then we put our parentheses. So I'm using that formula that we gave you. And then remember it was 1 plus R over N. R is the interest rate. So R is 6.5%, which is 6.5%. But remember, I got to turn it out of a percent into a decimal to use it in the formula. So move this left twice, and we get a 0.065. Okay, and you can do the calculator to take that 6.5 divided by 100, and it'll give you 0.065. So that's my R, 0.065, divided by my N. Well, N is the number of compounds, and they said this was compounded quarterly, so that would be 4 times a year. So we bring down our 4, and then it's 4 times T. So that's in terms of time like they wanted, right? After T years, if I know how many years the time is, I can use this formula and figure out how much my investment has grown after those years. Now, MathLab wants us to simplify this on down, okay? So they're going to give us the A of T equals. We're going to bring down our 83,000. Since this is just a number inside here, they want us to figure this out and simplify it. So let me clear that screen. This is 1 plus 0.065 divided by 4 in parentheses. So let's see what that equaled. Oh, yo, I didn't even need that parenthesis there, my bad. So let me hit enter and see what that equals. And I get a 1.01625, and then close parentheses and put your 4t. Now remember, the 4t is an exponent, so on MathLab, you got to use the little exponent key to put up that 4t. All right, so that's what it wants. It wants this part simplified, okay? Now, part B on this, they want to know how much money is in the amounts after t equals 0 years, 4 years, 7 years, and 10 years. So each time I'm just going to plug in for the t and get my amounts. So at t equals 0, let's see what we got. And we use this formula right here that we simplified every time. So I got 83,000 parentheses 1.01625 close parentheses, and then the exponent. So 0 years, 0 times 4 is 0. So basically my exponent is going to be a 0. When I hit enter, I get 83,000. So at t equals 0, I got 83,000. Well, that makes sense. That's my starting amount, and no time has passed yet, so I need to have my whole starting amount in there, right? All right, so t equals 4 years. What I'm going to do is put a 4 in for the t. So I got 83,000 parentheses 1.01625 close parentheses, and then my exponent at 4 years. 4 times 4 is 16, so I'm just going to make that a 16. Hit enter. And notice what I get. I get 107,000. So let me get that over here where I can write that. 420. And we're rounding these to the nearest dollar on these, okay? Now, at t equals 7 years, and I'm happy to see my investments going up, right? Very good. So now, at 7 years, the same formula, 83,000 times 1.01625 close parentheses, exponent. So now 4 times 7 is 28. So I'm going to make that a 28. Hit enter, and I get 130,300. And that looks like what, a 45, because that 8's going to round up. All right, then finally I got 10 years. So at t equals 10 years, I'm going to use my formula, 83,000 parentheses 1.01625 close parentheses, exponent will now be 4 times 10, which is 40. So we hit enter, and it looks like I get 158,161. And I'm not having to round the 1 up because that was a 3. Now, y'all, I'll show you what's cool about these calculators. I can go to y equals, clear this out. I can put in that equation we just made, 83,000, right? Parentheses, 1.01625, close parentheses. Exponent would be 4 times t, but since I'm using my graph, and my t will be an x. So now I've got that exact equation in there. I can hit second table, and let me get way up in here where these x's are down there where that 0 is, okay? So I don't know what I was doing on that. I must have been showing them an asymptote on that. So let me get back down here to the zeros on my x's. All right, so there's x equals 0. And if you notice, 83,000 is in the bank. Go over here to x equals 4. And x equals 4. Looks like what we get, 100,700. Oh no, am I on the right one? There it is, right? 107,420. Then at 7, so let's see, 5, 6. At 7, there's my 130, 345 because I rounded up. And then finally at 10, 158,161. So if you want to plot them in the calculator, you can use that table and use those x values for your values of your years and get those amounts. All right, let's see, number 5. Melissa's 6th birthday. So 6th birthday. she gets a $5,000 CD that has 6% interest, compounded semi-annually. So it matures on her 12th birthday. How much money will be available? So let's see, we're going to have to use our formula, amount available. So let's see how much time passed. Her 12th birthday, so T will equal the 12th birthday minus her 6th birthday when it started, which is 6 years. So since that's 6 years, we're going to find the amount after 6 years. So 6 is telling me what we're going to put in for the T now, since that's my variable. So we started with the 5,000, parentheses, 1 plus, my interest rate is 6%. So remember, 6% is the same as 0.06 in decimal form. So that's 0.06. I moved it twice left. N is the number of compounds. Semi-annual means twice a year, so we divide by 2. And then N is 2 times T. Well, we know the T was what? 6 years. So we can work this part out and get an answer. So here we go. Clear that screen. Let me quit. Clear. So here's my 5,000. Parentheses, 1 plus 0.06 divided by 2, close parentheses, and then my exponent is going to be 2 times 6, which is actually a 12. All right, so this one wants me to round to the nearest cents. So let's hit enter, and it looks like I get $7,128. And let's see, that's an 8 and a 0, but a 4 follows to 0, so that's just going to stay 80 cents. Okay, so that's how much will be available. So it went from 5,000 to 7,000 in just 6 years. So Melissa's pretty lucky, right? All right, number 6, find the logarithm. Log base 10 of 1. Well, if you wanted to, since that's a log base 10, you can use the log on front of the calculator because that's a log base 10. Put your 1 in, close parentheses, and you hit enter, you get 0. Any log, no matter what the base is, if that is a 1 sitting there, the exponent that you would raise that base to get a 1 always has to be a 0. All right, next page. Find a log. Log base 4 of 4 squared. So, what exponent would I raise 4 to get a result of 4 squared? Well, remember, you could also use that product rule that says we don't like exponents, so we bring them down to the front. So I get 2 log 4 of 4. And remember, the log 4 of 4 part equals 1, and 2 times 1 is 2. So anytime this base matches the base of the result, the answer is always going to be that exponent, because 4 to the second power equals 4 to the second power. And now, y'all, for that log base, you could have went math. So watch this. I could have hit, let me show you, hit the math button, go down till you find log base, hit enter, put in the 4, arrow over, and then put in 4 to the second exponent, hit enter, you get the 2. Okay, so logs can be done on here also. Right, number 8, log base 16 of 2. So same thing on that, go to math, arrow down to log base. Log base, you hit enter. So the base is a 16, arrow over, the result is a 2. When I hit enter, I get 0.25, but remember, math, enter, enter, gives me my answer of 1/4. Now, if you don't have that log base feature on your calculator, What you got to do for this kind of problem is the log of the top number divided by the log of the base. It's always the result divided by the base. Top number divided by the bottom. And they both have to have the logs taken, and you got to close parentheses. But watch this. Log of 2, close parentheses, divided by log of 16, close parentheses, equals 0.25, and then math, enter, enter. You still get 1/4. Either way, if you don't have the newer calculators, you got to do this change of base. All right, 9. Log base 28 of 1. Hey, same thing as while ago. I had a log base 10 of 1. That equals 0. Well, guess what? A log base 28, 1 equals 0, because 28 to the 0 power equals 1. 28 to the exponent 0 equals 1. Okay? Now let's do one more on this page and then we'll turn. Convert to logarithmic equation. 10 to the third equals 1,000. So to convert to a logarithmic equation, you got to write log. The base goes under here. So the base is 10 because that's the number the exponent's affecting. The result is the 1,000 because that's what this exponential equation has, is the result of a 1,000. And that has to equal the exponent of 3. Because remember, when it's written in log form, you're looking for the exponent as the answer. All right, y'all, let me pull this page off. That was 10. So number 11, convert to exponential, or to logarithmic still. E to the -5 equals R. So we got to write our log. Base is the E. The result is the R, and that equals the exponent of a -5. Now, since that's a log base E, I can put ln. Remember, that's a log base E. It's the same thing as a ln of R equal to -5. Okay, so remember, log base E's are ln's, and log base 10's are just logs. We call that the common log. All right, log base 4 of 64 equals 3. Now, since this is written as a log, number 12 wants me to convert this to exponential. So exponential would be the base, which is a 4, raised to the exponent, which is a 3. So 4 to the third power equals the result, which was a 64. So remember, these just go back and forth, okay? And we're using this property, log base b of x equals y, if and only if b to the y equals x. So remember, we learned that. So we're just converting back and forth. B goes where the b goes, y goes where the y goes, and x goes where the x goes. All right, same thing, convert to log, to an exponential. Log base a of m equals -y. All right, so my base is the a. My exponent is the -y, and that equals the result, which is an m. Now you got to keep these letters big and small in MATLAB if they give you capital letters or not, okay? All right, 14 said use a calculator to find a natural log base E. So you got an ln, which is a log base E, of 258.3. Now they want me to approximate this out to 4 decimal places. So ln's on the front of my calculator, 258.3, close parentheses. So we get 5.554. So let's see, that 1 has a 2 behind it, so it's going to stay a 1. All right, 15, find a log using change of base. So I got log base 8 of 14. Okay, so if you do have the math and the log base, you can punch this in just like it looks. So hit enter, your base is the 8, arrow over, the result is the 14. We're going to round this 4 decimal places. So I get 1.269, and that's a 1, and behind it is a 1, so that's going to stay a 1. So remember, the other way would be to change a base, which would be to do the log of 14 divided by the log of the 8. Remember, it's always the top one divided by the log of the bottom one. So log 14, close parentheses, divided by log 8, close parentheses, equals 1.2691. Same answer. Okay. All right, 16, express as a sum of logs. So you got log base 3 of 3 times 9. All right, so that means to take this log and distribute it and rewrite it as a sum. So you get a log base 3 of 3 plus a log base 3 of 9. It's written as a sum. I'm done. 17, express as a product. Log base 8 of y to the 15th. Well, to bring it as a product means to take this exponent and bring it down to the front and write it as multiplication so that you get 15 times the log 8 of y. Okay, so that's what they mean by writing it as a product. All right, so I need a new page, y'all, because we got pretty good problems coming up. 18, rewrite as sums or differences. Log base b of x to the 3rd, y to the 9th, z. So express as sums or differences. So the first thing, since this is all being multiplied, they're going to be rewritten as sums. And all we're going to do is distribute the log b first. So I get log base b of x to the 3rd plus log base b of y to the 9th plus log base b of z. So now it's written as sums, but I got to do one more thing. Since I got exponents on some of these, I got to use that product rule, the power rule, and bring the exponents and write it as a product so that this becomes a 3 times log b of x, plus this becomes a 9 log b of y, plus this one I stay the same, log b of z. Okay, we gotta bring the exponents down after we rewrite these. All right, same thing, log b of p to the 3rd, q to the 7th over m to the 5th, b to the 8th. All right, so if it's on top, when I rewrite it, it'll be positive because that's a product. But remember, the quotient rule for division says that anything on the bottom gets subtracted from the top. So this product down here, both being subtracted, will both become negative when I rewrite it. So anything on top is positive, anything on bottom is negative. And we're going to distribute log b to all 4 of those. So we get log b of p to the 3rd, plus we get a log b q to the 7th, plus I get a log b m to the 5th, plus I get a log b to the 8th. So we're going to bring exponents down, bring exponents down, bring exponents down, bring exponents down. Now, notice this b and p don't match, this b and q don't match, this b and m don't match, but this b and b do match. So this part right here, is going to become a 1. And when you bring the 8 down out front, you're really going to have 8 times 1, which is just going to give me an 8. So remember, when the base matches the result, the answer was the exponent, just like earlier. So this one here gives me a 3 log b of p. Plus this one gives me a 7 log b of q. Plus this one gives me a 5 log b of m. Plus, since this part was a 1, that gives me 8, and then that would be my final answer. All right, 20, simplify ln x squared plus 17x plus 70 minus ln x plus 10. So since it's being subtracted, you would rewrite it as a quotient, x squared plus 17x plus 70 would be all over the x plus 10. Then you would try to factor, because you got a fraction here. So you need to see if any factors cancel. So the factors have to be factored on top before you know if they'll cancel. The bottom x plus 10 does not factor. That's going to stay the same. So up here, we know that's a trinomial, so you're going to get an x and an x. 70 is positive, so you want both factors to be positive like the middle number. And then factors of 70 that equals 17, or let's think, how about 10 times 7? Now, I knew one of them had to be a 10, right? If I was going to be able to simplify that. So that's why I sort of cheated and said, the 7 and 10, this 10 got something that multiplies to make 70, and that was, of course, that, right? Because now you cancel those, so final answer is ln parentheses x plus 7. Okay, 21, same thing. Log x squared plus 7x plus 12 minus log x squared minus 16. All right, so let's see what. That's being subtracted, so I write it as division. X squared plus 7x plus 12 over x squared minus 16. So y'all, this time, since that's got an x squared down here, I'm going to factor the top and the bottom. So over here, you get your log. So here's my top. Here's my bottom. Everything's positive on top, so you'll have an x plus and an x plus. All right, now factors of 12 that equals 7 would be 4 and 3, which means when I factor this bottom, I better get a 4 and a 3 or one or the other, right? If I don't get neither one of them, it won't simplify. So remember, this is like x squared, so that's an x and an x. The last number is negative, so you got unlike signs. There's no x's in the middle, so that's like you got a 0x. So you want factors of 16 that subtract to get a 0, which would be 4 and 4, right? 4 minus 4 is 0. When you add them, 4 times negative 4 is that negative 16 when you multiply them. So now the x plus 4's cancel. So my final answer would be log x plus 3 over x minus 4. Now the reason I don't need parentheses on this answer like I did up here was because since it's in fraction form, the computer treats it like it has parentheses up there. It knows that it should, okay, in the math lab. Right, that was 21, so we're on 22. Solve for x. 2 to the 8x equals 8. So since I can rewrite 8 using the 2, because I know 2 times 2 is 4, times 2 is 8. So since I did that 3 times, I can rewrite this as 2 to the 8x equals 2 to the third, since I did that 3 times. Now, since the bases match, that means the exponents are equal, and 8x has to equal that 3. Now I would solve that for the x by dividing both sides by the 8, so that x equals 3 over 8. Final answer. All right, 23, solve 3 to the x equals 4. All right, so this one I can't rewrite. So when you can't not rewrite them to have the same base, you take LNs of both sides. So ln of 3 to the x equals ln of 4. So now you bring the exponent down to the front, remember? So you got an x ln 3 equals ln 4. And then our final step is to divide both sides by ln 3, because that's what's on side with that x. You want them to cancel. So x will equal, now remember, when you do these ln's, shut those parentheses, ln 4, close parentheses, divided by ln 3, close parentheses. And I'll round this 4 places, so I get 1.261, and then see, that's an 8 with a 5, so the 8 becomes a 9. All right, same thing, solve for t. E negative 0.04 t equals 0.27. Anytime you're looking for the variables to come down and you can't rewrite with the same base, ln. So ln of e to the negative 0.04 t equals the ln of 0.27. Now, since this is a log base e really of e, anytime you do a ln of e, all that's left on this side is the exponent, because the ln of e gives you a 1. So that leaves only the exponent, and that's going to equal the ln of 0.27. So that my last step is to divide both sides by the negative 0.04. So watch, when you do the ln of 0.27, hit enter, it gives you a negative, but now watch this, divided by a negative 0.04 gives me an answer that I can now round out. So my t equals, and let's see, around 4 decimal places, so that's going to be what, 32.7333. Now watch, what's neat is I can sort of check that. So if I do my e, so second ln, there's my e. So in parentheses, I'm going to do negative 0.04 times the t I bought, which was 32.73333. Remember, them threes kept going on, right? Close parentheses, hit enter. And notice I get pretty dang close to 0.27. I got 0.2700000, which tells me I'm pretty close. It just depends on where you approximate to how close you get back to your answers, okay? All right, y'all, 25. I got 12 to the x equals 4 to the x plus 2. All right, so I can't rewrite these, so I'm going to take LNs. So ln of 12 to the x equals ln of 4 to the x plus 2. Bring exponents down. Now, since we got more than one part to this exponent, I'm going to put it in parentheses. All right, so that's what x ln 12 equals parentheses x plus 2 ln 4. So the next step would be to distribute both of these times that ln 4 here, okay? So this side stays the same. This gives me an x times ln 4 plus a 2 times ln 4. So every separate exponent actually gets a ln, okay? Now to solve this, I need all the x's on this side. So I would subtract that x ln 4 from both sides. So I get an x ln 12 minus x ln 4 equals, all that would be left over here now is a 2 ln 4. Now, anytime you got an x in two different terms that are not like terms, you got to factor out the x. So we're going to factor out the x. So you get an x. If you factor out the x, that leaves you a ln 12 minus the ln 4, and all this is still equal to the 2 ln 4. All right, so guess what? Since this is x being multiplied by the parentheses, we're going to divide both sides by what was inside those parentheses. Okay? And over here, you got to make big parentheses around the bottom because you got more than one part. And each time you do your LNs, you got to put them in parentheses. So this side they cancel, you get your x equals. So let me show you how I'd put that in my calculator. So clear that. 2ln4, so 2ln4, close those parentheses, divided by, so this one had parentheses, big parentheses, ln12, close those parentheses, minus ln4, close those parentheses, and then close the big parentheses. All right, hit enter. We're going to round out 4 decimal places, so 2.523, and then the 7 has a 1, so I'm going to keep that a 7. All right, y'all, let's see what's next. Number 26. All right, so we're getting there. Solve for x. Log 5 of 2x minus 5 equals 2. So really, since I got a single log already, I'm going to rewrite this as exponential. So here's my 5 is my base. My exponent is the 2. And that's going to equal the result, 2x minus 5. That whole thing goes here because it was in parentheses. All right, 2 to the 5th is 25 equals 2x minus 5. And then, right, to solve this, you add 5 to both sides. So 30 equals 2x. And that's right, divide both sides by that 2. So that cancels. There's your x. 30 divided by 2 is 15. So if you put a 15 in here, 2 times 15 is 30. 30 minus 5 is 25. And the log base 5 of 25 is 2. All right, I can get my 27 right here. Let me slide that over a little bit. 27, same thing, log base 2 of c plus 21 minus log base 2 of c plus 5 equals log base 2 of c. So log base 2 of c plus 21 minus log base 2 of c plus 5 equals log base 2 of c. So since I got logs all over the place, I'm going to rewrite the single log on the left side. So it's going to be a log base 2 of the c plus 21 times the c plus 5 equal to the log base 2 of the c. Now I'm going to do one more step. Log base 2. Since we got two factors here, they're going to FOIL that real quick. So we get a c squared plus 5c plus 21c plus 105 equal to my log 2 of c still. Let's add like terms real quick. So log base 2 c squared plus 5c and 21c is 26c plus 105, all that equal to my log base 2 of c. So all we really did was FOIL that, and then right here we had to add like terms. Now, remember, I got a property that said if I got a log base 2 equal to a log base 2 on each side, that meant this result equaled that result, which means c squared plus 26c plus 105 equals this result of c. All right, so guess what? To solve these, we got to subtract c from both sides because it's quadratic. So I get a c squared plus 26 minus 1 is 25c plus 105 equals 0. All right, so y'all, let's see. Program, I can go, let me check this out real quick. Oh, I must have wrote that down somewhere. Let me see what I got. Log base 2 of c plus 21 minus log base 2 of c plus 5 equals log base 2 of c. So let me see, c squared plus 5c plus 21c. 21 times 5 is 105. That equals log 2 of c. All right, so I got to check something real quick, y'all. Oh, yo, I had this sign all wrong. I thought that was a plus. That's a minus. All right, so we don't want to do that. It's minus. My bad. So my bad. Log base 2 of c plus 21 minus log base 2 of c plus 5 equals log base 2 of c. My bad. I thought that was a plus up there, and I didn't. If that was plus, that's what we'd have done. But once I got here, it wasn't factor, so I knew something was up. So no, that's a minus. So these got to be written as division. So log base 2 of c plus 21 over c plus 5 equals log base 2 of c. So now when you rewrite it as a single log, it's got to be division because that was negative. So man, my eyes are old. One of my contacts is messing me up, but since that's negative, we got to write it like division. Now, since the logs match, c plus 21 over c plus 5 is going to equal this side, which is a c. So what I would do, put a 1 under there and cross multiply. This top times 1 is c plus 21. This part cross multiplies times that top. C times c is c squared plus 5 times c is 5c. So both of these multiply by both of that, okay? Now, let's move these over here and get a 0 because that's got a c squared. So we're going to minus a c from both sides, minus 21 from both sides. So this side gets my 0 equals a c squared plus 5c minus that 1c leaves 4c minus the 21. So now I'm happy because this will now factor c in c. That's negative, so one's positive, one's negative. Factors of 21 that subtract to get 4 are 7 and 3. Bigger numbers positive like the middle, smaller numbers negative. So then remember, set both of them equal to 0 and solve them. So I would subtract 7, c equals negative 7, add 3, and c equals positive 3. But remember, you got to check these answers because if you put a negative 7 in for that c right there, when you try to take the log base 2 of a negative 7, you get an error message. So you got to check negative answers for sure because you get non-real answers out of those if the logs are taken of a negative. Now this 3, that didn't hurt me. 3 plus 5 would have gave me an 8 there. That don't hurt me. 3 plus 21 would have made that a 24 there. That don't hurt me. All right, so always check your answers. So the only answer on that would be the 3, okay? All right, so I'm going to put 28 right here. Solve for x. Log base 2, x plus 7, plus log base 2, x minus 7, equals 5. So got two logs over here. We're going to write as a single log. And y'all guess what? This time they are being added. So I will write them as a product. X plus 7 times x minus 7 all equal 2 to 5. So that's going to give me my log base 2. So let's see. X plus 7 times x minus 7 gives me x squared minus 7x plus 7x minus 49. So the middles cancel because those are conjugate pairs. So you get an x squared minus 49. So that's going to go right here. And all that's going to equal 5. Now, since I got a single log on this side, but there's not a log on that side, I got to write it as exponential. So my base is 2, exponent's 5, and that's going to equal the x squared minus 49. All right, so let's see, what's that? 25 equals x squared minus 49. So I need everything on one side equal to 0, so subtract 25 from both sides. And I get 0 equals x squared minus, let's see, 64. So that's perfect squares, so I'm going to solve it by factoring. Now, if you use the quad, 1, 0, negative 64 for the quad. But that's a negative 64, so one's positive, one's negative. Factors in 64, that equals 0. Since there's no x, there's like a 0x there. So that would be what, an 8 and an 8. So setting them equal to 0 and solving, you get a negative 8 and a positive 8. So remember, if I put a negative 8 way back up into this equation, negative 8 plus 7 makes that a negative 1. So I cannot take that one. Let's see, 8 plus 7 makes that 15. 8 minus 7 makes that a positive 1 still. So I can keep my answer of 8. Okay, so those are not that bad once you get it written as your... All right, so this one has 10,137 at an interest rate of 6.6%, compounded continuously. So since it's compounded continuously, I got to use the formula P of T equals PO, which is my initial amount, E, K, which is my interest rate, T, which is my time in years. So they want me to find the exponential growth function. So that's going to be my P of T is going to equal my initial amount is at 10,137. E, K is my interest rate. Well, remember, 6.6% equals 0.066 because you moved the decimal twice to the left. So that makes that a 0.066 times T. Okay, so let me write that more clear because that's all jumbled. So you would get P of T equals 10,137 E to the 0.066 T. All right, then part B. What is the balance after? So balance after 1 year, 2 year, 5 year, and 10 years. So I'm going to start with 1 will equal this, 2 will equal this, 5 will equal this, and 10 will equal that. Now remember, if you wanted to, you can go to the y equals, graph this in y equals, but use an x for that instead of a t, and then go to 1, 2, 5, and 10 in the table and get all those answers. All right, so let's say I got 10,137. E would be second ln to get the e with the exponent, and my exponent is 0.066 times 1. So that's just going to be the 0.066, enter. And I get, looks like 10,828 and 61 cents. So round to the nearest cents. Now at 2, I would do the same formula, 10,137, second ln to get the e, 0.066 times t, this time would be 2. Now remember, if you got the old calculator that does this after exponents, and you only have to do 0.066 times 2, close parentheses, okay? All right, hit enter. and I get 11,567.42. All right, now for 5, I do 10,137. Second ln to get to E, 0.066 times 5. Enter. Looks like 14,124. And then finally for 10, 10,137. Second ln, 0.066 times 10. And that's going to give me, looks like 19,612 and 99 cents. So notice, I want to start with $10,000. So after 10 years, I've almost doubled my money just at 6.6%, which ain't bad. Now part C says, what is the doubling time? Doubling time formula is T equals ln of 2 divided by K, which is my interest rate. And that has to be in decimal form. So ln of 2 divided by my K. Now remember my K was what? 0.066. And ln of 2 divided by 0.066 equals 10.5022, and they want me to round one decimal place, so that'll be 10.5, and then they'll have the years there for you. All right, y'all, one more to go. So let me peel this paper off. And this one was sort of about a decay rate. So they give you a table over there. So I'm looking at my starting amount and my ending amount. So my starting amount was 1960, was 74.8. My ending amount in 2012 was 43.2. So it decreased, which means in my formula, I'm going to use the one where they had the M of T equals the M initial amount, E to the negative KT. So when you write the formula, you got to put a negative into it, okay? Because it's a decay. So the first thing you had to do was find K on this. So A was find what K equals. So to find K equals, you take the ending amount in 2012, which is 43.2. That's going to equal the beginning amount, which was the 74.8. E to the negative. K, we don't know, but T would be the amount of years in between 60 and 12. So that'd be what? 40 and 12 would be 52. Close parentheses. So what we're going to do is solve this for the K. So what you would do first is divide by the 74.8. Now I'm not going to divide that yet because I'm going to leave it as a 43.2 over 74.8. But this side I'm going to cancel it, and that's going to give me an E to the negative K times 52. Now I need to bring the exponent down, so I'm going to take an ln of both sides. Now remember the ln of this E over here. When I take the ln of E, all that's left is the exponent, which is a negative K times that 52. Now over here, the reason I did that like that, because to get more accuracy, you wait to divide until you start taking the ln of it. So ln of, now I'm still going to divide it, right? But the calculator can keep all my digits for me now. So 43.2 divided by 74.8. See, if I divided it up there, got that answer, then did the ln of that, well, I might stop going across that on my digits. I might not go as far as I need to get more accuracy. So when I divide that, now notice that gives me what? A negative 0.54897, blah, blah, blah. I ain't worried about that because I'm going to keep that answer on my screen and divide both sides by that negative 52. So see that negative, it's about to get divided by a negative. It's actually going to make my K positive now. So divide that by the negative 52, which will now give me a K of 0.010. Now they wanted me to go out 5 places, so that's going to round to a 6. So K is 0.0106. Okay. Now, part B was of that. Oh, that's still in part A when they wanted me to write the formula down. So they had m of t equals. Now, when I do this part, I take my starting amount, 74.8. I use the negative since I'm doing the formula now, and then I put in my 0.0106 for my K, and then T for my years. So now this formula can be used whenever I know what the T is for my years, okay? All right, so let me turn pages. I'll keep my formula handy. So part B, estimate the percent of adults who are married in 2015 and 2018. So let's start with 2015. So for 2015, let's see where I'm at. 2015, let's see how many years is that, starting at 1960. Was that my early year? Yeah, from 1960. So 2015 minus 1960, boy, that's going to be what? 55 years. So T is going to be 55 years. So I know what to put in for my T, right? So I go M of 55 is going to equal my starting amount, which was what, 74.8 times E to the negative 0.0106 times 55. All right, so let's see what that gives me. 74.8. Second ln to get my E, and then my exponent is a negative 0.0106 times 55. Now remember, old calculator, close parentheses. All right, so that gives me what, 41, round to the nearest one decimal place. So that'll be 41.8. All right, so now for 2018, well, 2018 is 3 more years than that, so 3 more would make that a total of 58 years. So we're going to find M of 58, which equals 74.8 times E to the negative 0.0106 times 58. So basically, same formula, we're just changing the years here, okay? So let's see, 74.8, second ln to get the E, negative 0.0106 times 58. Now, when I hit enter, I get, looks like 40.4. Well, that makes sense. If it's a decreasing table, then from 2015 to 2018, we almost decreased by another million if that's what the table was going by, right? All right, let's see. Next question is a part C, and it says, at this decay rate, in which year would the percent of adults who are married be 30%? So that's the ending amount. So I would put my 30% as the ending amount. My starting amount is still 74.8 E negative 0.0106. But notice this time what I'm looking for is the T, or the amount of years. Once I find the amount of years, I'll add that to 20 for what I start at 1960. Whatever I get here is the years. I add to 60, and that'll give me the new year. Okay. All right, so to solve this, we would first divide both sides by the 74.8. But remember, I ain't going to take the LN yet. I'm going to leave that as a 30 over 74.8. This side I'll cancel. E negative 0.0106 T. Now I'm going to take the LN, and then I will divide that, okay? So remember now, that's going to give me a number. So let's see what that'll give us right off the bat. So ln, so clear that, ln of 30 divided by 74.8. Now notice when I do this, since I'm not doing that change of base stuff, notice I didn't put ln of 30 close parentheses and then divide by ln of 74.8. Since this was supposed to be divided first, you got to put parentheses around the whole thing and just the one ln, okay? All right, so anyway, that gave me a negative 0.9136. This side, remember, ln of e is just going to give me the exponent. So now my last step is to divide both sides by the number in front of the t. Because those are going to cancel. And then that negative divided by negative makes that a positive t. So take that answer we had on screen, divide by negative 0.0106. And that's going to give me, rounding to the nearest year is 86 years. Right? But they want to know in what year will that happen. So 1960 plus 86 years. 1960 plus 86 equals 2046 is the year when the percent of adults married will be down to 30%. So notice in 2012 it's at 43. So you got what, about 34 years it's going to drop down to 30%, which is another 13%. So, I mean, is what it is, right? Right, y'all, that is the last question, number 30. So good luck. And don't forget to take that test 4 after you get good on this actual work, okay? All right, y'all, and I'm going to stop the video, and y'all have a good one.